Hello everyone, thank you for coming to another SPIN seminar. So yeah, we've got a slightly different topic today by Martijn van der Ende, talking about the landscape of academic publishing. So obviously a lot of us are just starting our academic careers, and kind of publishing is definitely something you always need to consider and think about. So yeah, hopefully this will be very useful for a lot of us. So yeah, Martin, take it away.
Right. Well, thank you very much, Eleanor, and also thank you for this invitation to present to all of you. Even though I cannot see you all in person, but from what I've heard, there is quite a number of you out there on Zoom. So yeah, this talk is going to be a bit different from what I normally do. So apologies if it's not as polished perhaps as my usual scientific talks. And so I split this talk into two main parts. Since I guess that some of you have not yet published anything yet, I'm going to take you on this journey through the academic publishing landscape from start to end. So discussing, a little bit about manuscript preparation, the submission process, and the editorial workflow. For those of you who already have experience in this, well, perhaps not everything will be new, but hopefully there will be a few elements that you can still pick out that you find useful. And then the second part is, well, the actual reason why I'm here, which is to talk about SEISMICA and also about open science in general. Okay, so let's say that you've got some nice results on your research project, and you're going to prepare a manuscript. Then the first thing that you have to decide about is which kind of software to use to write it all up, because there's of course Microsoft Word or Google Docs and LibreOffice on the one hand, and there is LaTeX with Overleaf on the other hand. So the main advantage of Microsoft Word and Google Docs is that it is very easy to share with co-authors. Most people, academic or not, they have either Microsoft Word or LibreOffice already installed on their computers. And so they have all the necessary dependencies, and they're able to open your documents. And they have this very convenient track changes feature, so that in the end, when you get back an email from your co-authors, you just hit accept all, and then you have all the changes in there. But it can be a bit tricky to have consistent writing of equations, numbering of figures, and also doing, for instance, citing other people's work, which of course there are some external plugins for that, but it can still be a bit tricky to set it all up within Word and Google Docs, etc. And also you should know that sometimes some journals actually charge extra for Word submissions versus LaTeX, which is a bit easier to typeset. So for instance, for the EGU Solid Earth journal, they currently charge 93 euros per page of Word documents versus 77 euros per page for a LaTeX document. So even though perhaps you don't even consider submitting here, this is something that perhaps you will find out afterwards after you receive the bill from the journal. Now, on the other hand, we have LaTeX, which is perhaps not something that everyone here is familiar with, and certainly not your co-authors perhaps. And setting this up can be a bit tricky, but fortunately there is this online editor called Overleaf that makes life a lot simpler in that respect. And unfortunately, there's not really this really equivalent track changes feature by default. LaTeX is a markup language. It's not really a software on itself. And even though Overleaf offers this as a premium feature, so if your university has a subscription with Overleaf, you can use the track changes online, but otherwise, if you just compile LaTeX on your own computer, it doesn't have a track changes feature really built in. But on the other hand, it's much easier to consistently write equations, refer to figures, and do internal referencing and things like that. And because you're writing essentially a form of code, you can also use version control. So perhaps those of you who already published 1 or 2 manuscripts, and if you do this in Word, then perhaps you have a folder that says draft 1, draft 2, final draft, final draft, etc., etc. That every time you may have to copy your document to keep track of the history of your manuscript. And with something like LaTeX, you can use Git, for instance, to keep track of all the changes and go back and forth, and also use this to automatically generate these PDFs that show what is different compared with the previous version. And I will show you an example of that a bit later. Okay, but this is just about writing your manuscripts. Another thing you need to take into consideration when you start preparing your manuscript is which journal you're going to submit your work to. And specifically, you have to keep in mind the audience that you want to reach with your work. Some journals are very domain specific, and so you can use a very specialist language, whereas other journals are much more multidisciplinary. And so the editors would like you to write your manuscript in such a way that it can be understood by a broader range of specialists. Then many journals impose restrictions on the maximum length of your manuscript in terms of the number of words or the number of figures and tables. Some journals specifically only publish letters, which are relatively short papers. And so if you have you did like a big research and you've got lots of results and in-depth analysis, then perhaps you need to find a journal that allows you to have longer manuscripts when you want to submit to. Then something that people also tend to take into account is the reputation of the journal or the journal impact factor. And I think most of you will have heard of the journal impact factor by now, but perhaps you haven't seen yet how it is exactly defined. So I've added this yellow box here, which shows that the definition of a journal impact factor is simply the number of citations that the journal has accumulated in a given year, divided by the number of citable objects in the previous 2 years. All right, so now we're in 2022, so the impact factor for the year 2020 and 2022 would be the number of citations in this year, divided by the number of papers and other objects in the 2 years before. And very often it is assumed that high impact factor equals high prestige. Although this is not always the case, there was this very curious case in 2009 where suddenly Acta Crystallographica received a journal impact factor that was close to 50, which was much higher than that of Nature and Science. And this happened because they published one paper that was some kind of like a landmark paper, and everybody cited that one. So it accumulated more than 6,000 citations in that year. And so suddenly the impact factor of the journal shot through the roof. So yeah, the link between impact factor and prestige of the journal is perhaps more of a correlation rather than a causal link. And also you may wonder what are citable objects, because of course you have the regular papers that are citable, but also editorials can be cited in principle. And also many people or some journals tend to publish conference proceedings, which of course are all citable contributions, but which do not accumulate a lot of citations. So journals actually do negotiate with Clarivate, the company that publishes a list of these journal impact factors, to decide what kind of objects should be included in the denominator here, whether editorials and conference proceedings should be included or not, which impacts the impact factor quite a lot. And also, if you have, for instance, review papers, which normally accumulate quite a lot of citations, then you can really wonder whether a review paper really constitutes impact. Like, does it generate really scientific impact if you summarize the research in the decade before? And for some journals, it just so happens that the number of citations is not uniformly distributed across a journal. It is actually quite common that there are a few papers that received a lot of citations and therefore really contribute a lot to the impact factor, whereas all the others perhaps do not receive as many citations, meaning that if you were to submit your work to a high impact factor journal, that it doesn't necessarily mean that you will be receiving as many citations as the impact factor might suggest. And then if you want to compare the impact factor across disciplines, this is really, really tricky because fields can be small, can be very big, can be very dynamic. And so the impact factor for different journals and different fields really can vary quite a lot. Okay, so if anyone ever mentions that we should submit to a journal because of the impact factor, then perhaps keep in mind these kind of footnotes that I included here in this box. And then the last thing to consider is a very practical one, and namely the fees that you might have to pay to get published in a particular journal. This is particularly relevant for open access journals, where you as an author have to pay basically the full value of the manuscript up front. So I took this picture from a poster from Gary Fanning, which he presented at SCAC 2021, where he compared the open access or the open access publication fees for some of the main journals in our field, and indicating that, well, if you want to publish in one of these journals in an open access way, you have to spend at least $2,000 US to be able to do so. So if you're at the end of the project and perhaps the budget has been expended, then perhaps you might need to find other funds to be able to publish with a particular journal. Okay, so once you have prepared your manuscript and selected a journal, it's time to submit your work to that journal. And one of the first things that they might ask you is to provide a cover letter. This is a bit of an outdated concept. Not all journals still require you to submit a cover letter, but those that do, for them, you just provide like a one-page letter in which you can mention, for instance, special circumstances, like have you discussed this work with an editor of the journal? Do you perhaps have data that are under embargo and cannot be made public yet? Things like that. You can also take this then to suggest a couple of reviewers, which can then help the editor to quickly go through the review process. And I think I should mention here that it's important not to just copy the abstract, because the editor will be seeing the abstract as a separate part of the submission. And so just copying the abstract is basically just a waste of space. And if you are submitting your work to a high impact factor journal like Nature or Science, then you might be tempted to say that your work is groundbreaking or cutting edge, and which may very well be true, but it's always good to explain why your work is so good, and not just saying that it is the case. Anyway, so after the cover letter, there are other things that you should upload, like your manuscript file. And for the first round, very often you can simply submit a PDF based on the templates that the journal provides on the website. And so you do not necessarily have to upload all the individual figures and all the LaTeX source files. Usually for the first round, they accept you to just submit a single PDF that contains everything. Unless you have supplementary materials, they go on a separate upload. And then at the same time, you might want to consider to submit a preprint either to an archive that is affiliated with a particular journal. So for instance, for the HU journals, there's this collaboration or this partnership with, I never know how to pronounce this, SOR or SOR. So basically they give you a one-click preprint submission possibility, and likewise Nature partners up with Research Square. So then again, you can, while you're submitting your manuscript to the journal, you can also submit it to a preprint archive. But there are also these independent archives like the Archive and Earth Archive, where you can submit a preprint to. But you need to keep in mind that not all journals allow this. So I've heard stories from the SSA journals like BSSA and SRL, and I know also for IEEE. It can be a bit problematic if you submit a preprint and then also submit to one of those journals. Depending on the license that goes on that preprint, the journal might reject your work straight away because then there's a mismatch in licensing. Okay, so just keep in mind, just check this when you submit to a journal that you are also allowed to submit a preprint elsewhere. Okay, so once your work is submitted, then there's a whole editorial workflow that gets triggered. First off, there will be either an editorial assistant or sometimes even the editor-in-chief who's going to perform a quality control, just making sure that all the components are there, that there are no figures missing, things like that. If there is any technical issue, they'll get back to you, and then you can fix that and resubmit again. And once everything is okay, the editor-in-chief will assign an editor to your manuscript, who will do a basic content check to make sure that it is within the scope of the journal and that it is suitable for the journal audience. Again, if that's not the case, they'll get back to you, and in this case, it gets rejected. So this is what we call a desk rejection, when the editor rejects your manuscript without sending it out to be reviewed. But if everything is okay at this stage, then the editor will assign your work to an associate editor. And this is where the magic happens. So what an associate editor will do is they will contact reviewers. And this can take quite a long time. Actually, during the lockdowns, I heard many editors and associate editors complain about how difficult it was to find reviewers willing to review manuscripts. And so it could take a very long time before the sufficient number of reviewers was found for any given manuscript. Then when the reviewers are done, the associate editor has to collect these review reports. Sometimes reviewers miss their deadlines, either they forget about it or they have no time. And then the associate editor has to get back to them, ask them if they're still going to submit their reviews, etc. But okay, once they have collected all the review reports, this editor will then evaluate the reviews. It could very well happen that if you have one editor or one reviewer who is like, thinks it's great work, and one reviewer who thinks it's terrible, then that the editor will go back and find another reviewer as a tiebreaker. And so then we have to go through that cycle again. But then once finally everything is ready and there is a consistent evaluation of the review reports, then the associate editor will make a recommendation to the editor, who will then make a decision on whether your manuscripts can be accepted or not. And so from these decisions, there are various flavors. So the most favorable one for authors is accept. There are no more changes needed. It can be published right away. But most of the time, you will find that some revisions are required. And these are often categorized as either minor or major, or minor, moderate, and major, which means that it will be sent back to you. And you have to improve the manuscript, and a new version will be expected within usually a few weeks. Then there is another way to, well, incorporate revisions. That is through a recommendation. It's called rejection with resubmission. So in this case, if the manuscript is really unclear, or if there's like, if it's required to add a lot of data or things like that, then they will recommend you to resubmit at a later time, which means that you can work on it. You can take as much time as you need and then resubmit to the journal once it's ready. And even though it sounds very harsh to get rejected, sometimes it's actually more favorable to get this rejection or resubmission, because then there is no deadline. Then you can just take as long as you need to fix the manuscript and before sending it back. Whereas if you have, for instance, major revisions, then you need to send it back within 3 or 4 weeks, which, depending on the revisions that are required, could be a bit short. And so an associate editor may, for instance, recommend rejection or resubmission if they think that it just takes more time to incorporate all these changes. But the worst possible case for us is rejection without resubmission, which means, okay, we don't want to see you again. Basically, it's as short as that. Now, as an author, you can actually appeal against these decisions. At least most of the journals allow you to send an appeal. So if, for instance, the reviewers completely misunderstood the point of your paper, and if it's just a matter of clarifying a few things to address the reviewer comments, then you can send an appeal to the editor, and then they will reconsider their decision. I've done it myself a few times, and every time I've been successful in getting another opportunity to resubmit to the journal and then try to address the reviewer comments in that way. Now, the way that you address the reviewer comments is usually through a rebuttal. So this is basically a document in which for each comment you answer or you clarify what has been done, what has been changed to address that comment. And even though you're writing in response to the comments from the reviewers, I think its main purpose is to actually convince the associate editor first and reviewer second. Why? Well, the associate editor is the one who makes the final recommendation, right? If you resubmit your work, then the editor will look at it and look at your rebuttal. And based on that, it will decide when it goes back to peer review or when it can get accepted right away. And so it is important that in the rebuttal, you are clear and to the point. I mean, most editors are busy people, and so they don't have much time to go through a very, very long reply. So if you can be short and to the point and make everything as clear as possible, that really helps in smoothing over this whole process. So for instance, what you should do, I think, is if you make changes in the text, you just copy that kind of text into the rebuttal rather than just referring to line numbers, in which case an editor will have to go back and forth between the rebuttal and the manuscript. Okay, so another thing you have to provide during the revision stage is a document that highlights all the changes that you made in the manuscript. So here on the right is an example, and usually you do this with different colors and strike throughs and boldface and things like that. If you want to generate such a document with Word or with Google Docs, then I haven't seen any automated procedure for that. So I think you just have to do this manually, where you highlight yourself the things that you changed, either coloring it or strike through or things like that. But with LaTeX, because you are writing code, you can automatically compare 2 different versions and then generate automatically a PDF that highlights all these changes. So the one on the right here, this example, this shows the output of such an automated comparison. And then also journals tend to require you to submit publication-ready files after the first round. So when you are revising your manuscript and you're resubmitting, there is a chance that the editor will accept your work right away, in which case the journal would like to have all your documents like Word or LaTeX files, figures and high resolution, so that it can go to production right away. Okay, so in this flowchart, we are now here. So we had just had an editorial decision. If we had revisions that are required, we are going through the loop again. If it's rejected, then that's too bad. That's the end of the line for us. But at some point, hopefully it gets accepted. And then as an author, you can mostly sit back. So what the journal will do is they will mint a digital object identifier, a DOI, and include that or put it on your manuscript. And we'll pass it on to a copy editor who will start the typesetting process. Then they will generate a manuscript that has all the like the journal logo and the nice font and the page numbers and everything on there. And they'll send you the proofs. And then you will have to assess these proofs and check for any typos, for equations that have been poorly formatted, figure positions, names of like your co-authors if they're entered correctly and things like that. And usually they only give you one round of proofreading, meaning they send you a document. You have to indicate in the document what is wrong, and then you send it back. And after that, then it's over. So you do not get a chance to go back and forth with most of these kind of journals. Okay, so if that is all done, then eventually it will appear on the website, nicely formatted, and then your work is published. But this is not yet the end of the line, because there's still the small matter of the payment. So as an author, especially if you publish open access, you do have to pay. And sometimes the journal also offers some kind of promotion package. So they give you a little spotlight on Twitter or Facebook. And depending on the journal, you might work together on creating a bigger splash on the internet. Okay, and so when your work is finally accepted, make sure to celebrate. It's always a very nice message to get in your mailbox. Congratulations, your paper has been accepted. And then your co-authors will send you, congratulations, well done. And that's a bit like, your birthday. So it's always nice to have a paper accepted. Okay, now this is all about publishing in general. I now want to move to the topic that is actually a bit closer to my heart, that is the journal SEISMICA and also open science. And let me start with the open science part. Probably many of you will have heard of the term open access. And by that, people usually refer to gold open access. So gold open access is a publishing model where the version of record, so the final manuscript, is freely accessible on the publisher website. So anyone can access the paper that you just published. And also very important is that the copyright, in this case, stays with the authors. And if you do not publish in an open access model, then very often the copyright rests with the publisher. So basically that means all the figures that you made and all the data that you put in your paper belong to the publisher, not to you. So with gold open access, copyright rests with you and your co-authors. And so in principle, you're allowed to use your own figures in, for instance, lectures and things like that. But this comes at a cost. So authors are expected to pay a fee upfront. These are usually called APCs, or article processing charges. And these can be pretty expensive. I've shown a figure before where the open access fees range from about $2,000 to up to $10,000 US. But fortunately, there are many of these national programs that offer either waivers or discounts for APCs to encourage gold open access publishing. So for instance, in Germany, the Netherlands, UK, if you want to publish open access, then you can basically send the bill to your government, and then the taxpayer will pick it up. Okay, now this is not the only form of open access that is out there. Green open access is actually quite a bit simpler, where you, for instance, can do self-archiving, where you have the version of record that you upload to your personal website, or you can upload it to an institutional archive like a university repository or a national repository or something like archive. But this is often not permitted with the publisher license agreement. So when you publish with a particular journal and you choose a closed access license, meaning that you pay less or you pay nothing at all, but that the manuscript is not freely available, then in that agreement that you probably do not read but still sign, it says that this kind of green open access publishing is not allowed, or at least not until the embargo has been lifted, which sometimes does not even exist. Now, there is also a third version of open access publishing, and that's called Diamond Open Access. So Diamond Open Access kind of combines the best of both green and gold open access publishing by offering the version of records also via the publisher website, and it will be open to everyone. And also the copyright stays with the authors, but there are no article processing charges, meaning that a publication is free to read, but at the same time, for authors, it's free to publish as well, while still being peer-reviewed. And actually, there are probably more Diamond Open Access journals out there than you might think. Sometimes an institution like a university or a research lab, they fund these kind of very small-scale journals where people can publish with them, and then they release a few papers per year. And in this case, all of the publication costs are covered by the institution, and that way everyone can access the research, and at the same time, the authors do not have to pay anything. Now, this is about open access publishing, but open science is bigger than just publishing manuscripts under an open access license. Open science includes open access to publications, as we've seen before, but also software and codes, which you can, for instance, upload to GitHub. Open access to data. So there are these repositories like Zenodo, Fixshare, Dryad, EPOS, where you can upload your data to. You will then be assigned a DOI, meaning that your data can be individually cited. Very often you combine this with a journal publication. So you have publication and you have a data set, and both can be cited individually, but you can sort of link them together so that people know that there is a paper and the data that go hand in hand. And also there are even initiatives to provide open access to physical samples. So if you do field geology or you do lab experiments, there are ways to store samples such that people can access them, so that they can redo particular analysis on your samples. Now, one of the very important features of open science is that the copyright remains with either the original creators, which is you as an author, or that the copyright remains within the public domain, meaning that everyone owns it. And for many content types like code or data or publications, you can choose an appropriate license. Now, what a license does is it codifies explicit permissions, conditions, and limitations related to your work. So in a license, it just summarizes what people are allowed to do with it and what people are not allowed to do with it, or if there are particular conditions under which you are allowed to make changes or things like that. So some examples of common licenses are the Creative Commons licenses, CC, which are often put on publications. But there's also MIT, GPL, Apache, and the unlicensed, which you can put on software. And there are many, many other different flavors. And you can find a few of these on choosealicense.com, which lists the main licenses that are available to you. So very often a license is perceived as something purely technical and purely legal, and it's all very complicated. But there's actually a very nice structure to some of these licenses. So for instance, the Creative Commons license, The most basic version of that is CC0, which means no rights reserved. You waive your copyright and everything is put in the public domain, meaning that everybody owns it. So this is just a very, very simple, very permissive license. You can do anything you want with it. When you put this label on there. But then there is the more common CC BY license or CC BY license. This is a rather permissive license, so people can do a lot with your work, but credit must always be given to the creators, which is something that I think is very nice. And then on top of that, you can stack more limitations. So, for instance, you can do CC BY SA, meaning that SA means that adaptations must be shared under the same terms or the same license. So if you release some code and someone changes the code a little bit and wants to publish it, then they have to also publish it under the same license. The NC clause is for non-commercial use. So if you do not want people to use your code, your data, or your work for commercial activities, then this will prevent that from happening. But you should keep in mind that under commercial activities also falls teaching and also research, right? Because we are being paid for what we do, at least most of us. And so if we go to a conference and we take a figure from one paper and we put it in there, or we take code from someone and then apply it to our own data, that technically constitutes commercial use. And so with this NC clause, it's very, very restrictive in our particular domain. So I would not recommend people to add this. And then lastly, there is the no derivatives clause, the ND clause, which basically means that you're not allowed to modify whatever is in there. So if you have a paper, that means it's not allowed, you're not allowed to translate it to a different language. Or if you have code, then no one is allowed to change the code a little bit and then republish it. So effectively, you can stack all of these kind of license options, and then you get, for instance, CC BY and CND, which looks like a very, very big thing, but it just means, okay, you have a relatively permissive license, but it requires people to attribute the original authors. Commercial use is not permitted, and you're not allowed to modify the contents. That's kind of what it comes down to. All right, so this is perhaps a little bit technical about open science and how open science works in the real world. But I've actually been invited to come here to talk about something else, which is SEISMICA. So SEISMICA is a recent Diamond open access journal that was launched this year. It is a journal that was created by the seismological community. So myself and others, we all contributed our time and effort to get this journal started. And the idea behind it is that we want to publish, of course, in a Diamond open access way. So it will be free to publish, but also free to read. But also we want to experiment a little bit and make sure that this journal really serves the seismological community. The scope of SEISMICA is very broad. So if you do theoretical seismology, or if you do, say, earthquake source inversion, or planetary seismology, or anything in between, even things like engineering seismology, teaching, outreach, instrumentation, things like that, all of that can fit within the SEISMICA journal. And so with our journal, we're trying to basically serve the community as much as possible. And the way that we got started was actually, it's very nicely summarized in these two tweets over here. So the tweet on the left is the announcement from the Nature Publishing Group to allow open access submissions or open access publication subscriptions for authors in Nature and some other sub-Nature journals. and they offer this at the price of 9,500 euros, or I think it was something like $10,000, something like that. And so this is a pretty steep price. Even in earth sciences, we relatively pay a lot for publishing compared to some of the other fields. But still, even within our own field, we had a lot of backlash to this very steep pricing model of the Nature Publishing Group. And soon after, Jamie van Casson, he is the editor-in-chief at a journal called Volcanica. And he explained to us that basically the running costs for Volcanica are less than 500 euros per year. And so for the price of a single open access paper in Nature, you can fund the entire journal for 20 years. And this is also a diamond open access journal, meaning that authors nor readers have to pay for getting access or getting published in this journal. So for the price of a single paper, you can fund open access and open science activities for 20 years. And so based on this, on Twitter, we were debating and discussing about whether we should actually start our own journal following the model of Volcanica. So at first we were just discussing in different Twitter threads, and it's always a bit chaotic, but it was mostly just complaining. But then we really decided to get serious with this. So we started a Slack workspace and invited lots of people to participate in this. I think right now we have 250 people in the Slack workspace. And so there we really started to discuss some of the details and really committing ourselves to this effort. So I then decided to form a task force with a bunch of people. We really invested a lot of energy and time in exploring the feasibility of starting a journal just like Volcanica. So we had lots of discussions with people from Volcanica, but we had also lots of discussions with librarians, people working more at the government level to see what kind of opportunities there would be for startup journals like ours. One of the main challenges, which turned out not to be a challenge at all, was, for instance, to find a host institution. So if you are going to publish for free, meaning that authors and readers both don't pay, then there's no money coming in. And so we need to find an institution who's willing to foot the bill. And fortunately, we very quickly found that the McGill University Libraries actually had this entire infrastructure in place. They already had several diamond open access journals under their umbrella. And so SEISMICA would just be yet another journal for them, but this was actually the first one in the STEM field. Other things that you need to decide when you start a journal, for instance, how do you structure your editorial board? Do you have an editor-in-chief? Do you want people to stay for 2 years and then leave, or do you have extensions? Do you vote for people? Things like that. Also, what kind of publications do you want to offer in your journal? How do you consider your brand identity? So all these kind of things you had to think about and decide on before really we're ready to go. Then at some point, we were able to define the journal well enough to start the recruitment of people who are going to sit on this editorial board, which took us a long time, but after a few months, we managed to get there. And then among those people who we just recruited, we had to distribute tasks like drafting guidelines, policies, building websites, things like that. But I think it took us about 1.5 years, but then finally on the 1st of July, we were able to go live, which means accepting manuscripts. So I think I saw Sven in the group here. He was the first to submit to SEISMICA. So thank you for contributing to us on day one. So what is perhaps a bit different about SEISMICA compared to other journals is that aside from the regular contributions and regular papers that we publish, we also publish a format called fast reports. So this is meant for very short articles with only a few figures that have a very short turnover time. And they're mostly should be focused on things like recent earthquakes that happened. Normally, whenever an interesting earthquake happens, people talk about it on Twitter and they post their finite fault inversions and back projection results and deconvolutions and everything on Twitter. But of course, it's not sustainable, it's not citable. And so we want instead people to publish this within SEISMICA so that it can be DOI stamped. You can cite it. It will be reviewed by dedicated reviewers. And this is much more sustainable than just sharing things online on Twitter. Aside from that, we also have reports for instance, software and data and seismic deployments. So if you have a temporary seismic campaign and you want to explain in detail all the technical aspects of this deployment, there is room in SEISMICA for that kind of publications, which are hard to publish in most of the journals in our field. And finally, there is one particular type of publication which we call the null results, which in a way you could call failed science. So very often we try things and they don't work. And usually they don't work for a good reason. But because they don't work, we don't have results that we can publish. But it's still very interesting to learn from other people why things did not work. So if there's something that didn't work for you, but for a very interesting reason, you can still write it up and submit it to SEISMICA, because then at least the rest of the world can learn from your mistake in a way. So I'm not talking here about, well, you forgot to connect the battery to a seismometer, but I'm more talking about physical limitations of what you try to measure, things like that. All right, then a few more quick other aspects about SEISMICA that are perhaps a bit different from other journals is that, for instance, we offer multiple abstracts and multiple languages. There's an example here on the right where we, in addition to the regular English abstract, we also have abstracts in, I guess we have Spanish, we have Italian, we have Japanese, we have French, all of this on a single paper, which can really help you to reach local communities or local press if you're reporting about, for instance, an earthquake in a particular region that is of interest to people who actually live there. Then when your paper is accepted, very soon you will get an email from Twan Win, who is in the picture over there in the bottom. She is leading the media and branding team, and they really help you to give you as big as a spotlight as possible on the social media that we are connected to. We have multiple rounds of proofreading. So like I mentioned before, usually you only get one round, one chance to correct all the mistakes. And then you send back your corrections to the journal, and then they suddenly publish it. And with us, and also with Volcanica, you can go back and forth. So if you think that a figure is not in the right position, you want to try it in a different place, maybe a bit bigger, a bit smaller, we can go back and forth with you to make sure that everything is exactly as you want it. And then I think the last one I would just mention is that we also have a pretty large focus on, for instance, outreach and education. Things that are not really considered to be scientific, but are still very, very important for our field. And so we're trying to integrate that within the journal. All right, so if you're interested about this, there are various ways of getting involved with us. First off, we are mostly present at some of the larger conferences. So over the last year, we've been at EGU, ESC, AGU, SSA, GSA, and SCAC, and a few others. So if you go to a conference, there's a very good chance that there is someone from SEISMICA who's there you can talk to. We'll be launching an ambassador program as well, and the first meetings for that will take place this November. We have also a reviewer database. If you're interested in reviewing for SEISMICA, you can sign up with your ORCID and you can just indicate what is your expertise. And then you might receive an email from one of the editors asking you to review one of the manuscripts. Also, the editorial board is very dynamic. And so there will likely be various rounds of recruitment to get more people handling manuscripts, or people who can, for instance, maintain the website, do typesetting, provide translations, things like that. And of course, we're all always present on social media with the We Are SEISMICA handle on all platforms. Okay, then the last thing before I wrap up is that SEISMICA is not alone. Of course, I mentioned Volcanica, but also in other disciplines, so in tectonics and sedimentology and geomorphology, there are also other Diamond Open Access journals who either just got started or who already have been running for a little while. So if pure seismology is not your thing, or if you're most interested in, say, volcano seismology, then you can also find similar initiatives in the other domains of earth sciences. All right, well, I think I'm already way over time, so I'm just going to wrap up with this. If there's one take-home message that you should remember, is that you can create impact with your research by publishing open access, whether it be green, gold, or diamond. As long as it's open, people can read it. You can share your codes and data under a particular license so that other people can use it. And you can participate in community initiatives like SEISMICA, Volcanica, Tectonica, and all the others.